Understand the concept of entropy. Entropy is a thermodynamic measure of the molecular disorder or randomness of a system. At the particulate level, entropy is determined by the number of possible microstates, arrangements, available to the system. Relate physical states of matter to entropy. Because of the differences in particle freedom and spacing, solids have highly ordered, locked crystal structures and the lowest entropy. Liquids have more freedom of movement and moderate entropy. Gases have particles that are widely separated and free to move rapidly in all directions, giving them the highest entropy by a wide margin. S gas GG S liquid greater than S solid. Establish the rule for chemical reactions. The sign of the standard entropy change, delta S degrees, of a reaction is primarily governed by the change in the number of moles of gas. Delta N gas equals moles of product gas. Moles of reactant gas if a reaction produces more gas molecules than it consumes. Delta N gas greater than 0, or converts a solid/liquid into a gas. The system becomes significantly more disordered, and delta S degrees is positive. Delta S degrees greater than 0. If a reaction consumes gas molecules, delta N gas less than 0, the system becomes more ordered, and delta S degrees is negative, delta S degrees less than 0. Evaluate option C. CaCO3 gives CaO plus CO2 reactants. 1 mole of solid, CaCO3, 0 moles of gas. Products, 1 mole of solid, CaO, and 1 mole of gas, CO2. Since this reaction starts with a highly ordered solid and produces a gas, there is a net increase of 1 mole of gas. Delta N gas equals +1. The gas molecules have a vast number of positional microstates compared to the rigid solid reactant, leading to a highly positive standard entropy change, delta S degrees greater than 0. This confirms option C is the correct answer. The correct answer is option C. CaCO3 gives CaO plus CO2.